Namaste to all of you. In this video, we would like to discuss about the numericals based on hardness. So we have an idea about the hardness. What is hardness? Hardness is a particular tendency which is found in water samples, and we can define the hardness, the presence of chlorides, sulfates, carbonates, bicarbonate, salts of calcium and magnesium particularly. This presence of these salts is called as hardness. So we generally determine this hardness in a laboratory by a method called complexometric titration. Complexometric EDTA titration. And we after determining the hardness, we can calculate the particular hardness via a formula, and the formula is N1 V1 is equals to N2 V2 is equals to N3 V3. Here the terms are their normal meaning. N stands for normality and V stands for the volume, but for the simplicity we can write on the top of the particular or on the bottom of the particular terms. Here we can write N1 V1, this is stands for standard hard water. This is stands for standard hard water. N2 V2 stands for particularly the EDTA solution, and this term stands for unknown hard water sample. So N1 belongs to normality of standard hard water, V1 belongs to volume of standard hard water, N2 belongs to normality of EDTA, V2 belongs to normality of EDTA, and N3 belongs to unknown hard water normality which is to be calculated out, and V3 is the volume stands for the unknown hard water. Generally the V1 volume is a pipette volume. It is of pipette volume, which is this volume may be 10 ml or 20 ml, and this V3 is also a pipette volume. It is also a pipette volume which is also a ml, 10 ml or 20 ml. And this V2 is of two types. This V2 is the volume of EDTA solution, disodium salt of EDTA solution, and first this V2 is for the it is for the standard hard water, and second time it is used for the unknown hard water. So when the first reading comes in the form of sky blue color. This is for the standard hard water, because we have taken the standard hard water volume first. Then second time, this reading belongs to the unknown hard water sample, which is which is to be calculated out, and this is the volume regarding the EDTA. Now we have an idea, a particularly formula. This formula is strength or concentration or, in this particular case, hardness is equals to normality multiplied by equivalent weight. So if the strength is given, normality can be calculated out. If the normality and equivalent weight are known, strength or concentration can be calculated out. So here, if the strength is given in a particular gram per liter, then normality is calculated out when we multiply equivalent weight of calcium carbonate 50. We know that hardness is calculated out in terms of, in context of uh, calcium carbonate equivalents. So we multiply here in normality 50, and this normality is equals to the strength divided by 50. So now you can calculate it out the n, that means the value of this n1, if the n1 is not given directly in the form of normality, rather it is given in the form of strength or concentration. Okay, so now we can calculate the particular this hardness using this formula n1 v1 is equals to n2 v2. So we have a formula n1 v1 is equals to n2 v2 is equals to n3 v3. Okay, if we put here normality in place of normality 1 by 50, then v1, suppose 10 ml, is equals to n2 into v2, which is suppose a particular volume x ml. Okay, so to calculate n2, we can write n2 is equals to 1 by 50 into 10 divided by x. So you get here n2 is equals to suppose a. Okay, here we use a one part of the formula n1 v1 is equals to n2 v2. Now the second step, this is the step number A. We can write here for this step calculation of n2. Now the B step, calculation of N3. So to calculate the N3, the formula is N2V2 is equals to N3V3. Here N2V2 means the EDTA values, the values for EDTA, normality and volume, and N3V3 the values related to unknown hard water sample. So we have N2 from this first step. So A multiplied by V2. Now V2 is the volume of EDTA solution for this unknown hard water sample. So here suppose the volume V2 is Y ml is equals to N3 to be calculated out, and V3 of course 10 ml or 20 ml. Okay. So you can calculate here A multiplied by Y divided by this particular 10 is equals to N3. So you get here N3, suppose a certain value B. Okay. After this, now the step number C, third step, calculation of now hardness. Calculation of hardness, the unknown hard water sample. Okay. So the formula is, what is the formula? Formula is here, strength or concentration, or in this particular case hardness, is equals to normality into equivalent weight. So we have now normality in the form of N3. So we can write here hardness is equals to normality N3 into equivalent weight 50. So normality is B multiplied by 50. So you get here the answer, the hardness here, you get the hardness here is equals to certain value in gram per liter. Okay. Now hardness is calculated out in the 4 particular units: milligram per liter, parts per million, degree French and degree Clark. So to convert this gram per liter into milligram per liter, we can write here hardness is equals to this gram per liter multiplied by 1000. So after multiplying the 1000 in this particular value, you get the answer in milligrams per liter, which is nothing, is also called as parts per million. This milligram per liter can also be converted into degree French or degree Clark. If you multiply this milligram per liter by 0.1, so you get the answer in degree French. And if you multiply this hardness milligram per liter by 0.07, you get the answer in degree Clark. So this is the lecture about the numericals based on hardness. One more thing also, if here this normality, which is 1 gram per liter, here 1 is in gram per liter, if you take this normality 1000 milligrams, that means strength, if you take strength in 1000 milligrams per liter divided by 50, So you would find directly answer in the degree in the parts per million or milligram per liter. You have no need to multiply this 1000 in the gram per liter. Thank you very much.